Hello friends, now we will see some important numericals from BJT. These numericals have appeared from simplified current expressions, that is expression for collector current and emitter current. The first question which appeared in 2004, that was of 2 marks, the neutral base width of bipolar transistor biased in active region is 0.5 micrometer, that is base width. The maximum electron concentration and diffusion constant in base are 10 raised to power 14 per centimeter cube, and that is diffusion constant is 25 centimeter square per second respectively. Assuming the negligible recombination in base, the collector current density is. So you have to find the collector current density. You are given these two parameters. So let us see the expression of collector current. We know the collector current is nothing but emitter current which is being injected from the emitter junction. This is what we assume. What is the type of BJT? That is not mentioned here. So you can assume PN or PNP type. But since we are given the electron diffusion current and electron concentration, so this is NPN transistor. So collector current density is given by what? Collector current density is same as the emitter current injection, emitter current density which is being injected from the emitter junction, and that is given by this relationship. Fine. So Dn is given to you, Q is given to you. Let us see further. We know the relationship between that the concentration of the electrons, that is concentration gradient of electrons, is given by what? Nb minus 0 by 0 minus Wb, that is given to you. I have already discussed this thing in theoretical part, so just by putting that relationship here, I'll be able to get the expression. You are given Q, you are given Dn, you are given Nb0, and you are given this thing. Fine, so I will get this here. Now, consider two BJTs biased at same collector current. Area of emitter is this and this. This is definitely area. Assuming that all other device parameters are identical, Kt by Q is given to you, intrinsic carrier concentration is given to you, charge is given to you, how to find VBE minus VBE2. So let us see the collector current. This is the expression of collector current. I have shown this thing. I had derived this expression in my video on collector current. So IC is proportional to what? All these parameters are same. The different is what? VB and AE. So IC is proportional to this factor. So IC upon I1 will be this ratio. So let us see it further. So what is given to you? IC1, IC2, VT, all these parameters are given to you. Just by putting those parameters into this and collector current being same, you get the difference between the two. This was the question in 2014, 2 marks question. Let us see the next numerical, that was in 2015, 2 marks. An NPL BJT having reverse saturation current IS is equal to 10 to the power minus 15 ampere is biased in forward active region. Reverse saturation current is given to you. VB is given to you, that is forward biasing voltage for active region. The thermal voltage is 25 millivolt. Current gain beta varies from 50 to 150 due to manufacturing variation. The maximum emitter current is given by. So let us see the collector current. That is the relationship of the collector current. VBE, basically this VE here is nothing but that is VBE. I will make a small correction here. That is VBE. Fine. So just taking small time for correction. So this is the relationship. So here what I find, I am given all these parameters, so I will be able to get, I get your collector current from these relationships. Beta range is given to you, so from range of beta I get the range of alpha. If beta varies from 50 to 150, so I get range of alpha, and we know relationship between IC and IE. So from that relationship you get the range of emitter current, and you have to find the range of emitter current. So you get first value of emitter current and then second value of emitter current, that's second value. So you get the range. And maximum current, of course, the question was, sorry, So maximum ammeter current, that is the range given to you, but maximum ammeter current is this much from the two values of alpha we get. Then let us see the next numerical. The injected excess electron concentration profile in base region of NP and BJT biased in active region is linear as shown in figure. If area of ammeter base junction is 0.001 per centimeter, that is centimeter square, mu n is given to you in the base region, depletion layer widths are negligible, then collector current you have to find. So you are given the profile, then concentration, the base width is given to you. So, and we know if concentration at emitter junction is known, base width is known to you, and you know the expression of collector current I have just discussed in my previous solution. So IC is what? Q, AE, dN, dN by dx. So all the parameters are given to you. Dn by dx is LB minus 0. This is given to you, this is given to you. So you get the collector current here. So that will be the expression for collector current. So by putting all the values given to you, you get here the collector current like this. So the questions are simple. Questions are directly based on the formula, provided you remember all the formulas and concepts. Fine, let us see the next question. For an NPN transistor connected as shown in figure, VB is given to you, given that reverse saturation current at room temperature is 300, that is 10 power minus 13, emitter current is. So you have to find the emitter current, and we know when base is connected, shorted with the collector region, so this and this is shorted, so you have simple PN junction behaves like, so this combination will be behaving like simple PN junction diode, and current of the diode is given by this relationship. So here it is emitter current, VD will be simply VB, so I will be replacing that by this relationship. VD will be equal to VB here. So VD is VB, I naught will be, ID will be simply emitter current. That is emitter current. So that's it. So these are the questions which appeared from, that is simplified expressions of the currents of BJT. Then components of current in BJT. For a BJT, the common base current gain alpha is given to you. Collector base junction reverse saturation current IC naught is given to you. This BJT is connected in common emitter mode and operated in active region with base current, that is this much. The collector current for this mode of operation is, you have to find the collector current, and we know collector current is given by what? IC beta into IB plus 1 plus beta. So beta can be written in terms of alpha because alpha is given to you. So just by putting all the values given to you, you get the collector current. That's it. So these are the questions which appeared from the, basically these are numericals which appeared from the current relationships. So just revise these, or see my video on the topic, and then try to solve all these numericals. You won't face any difficulty at all. So now other questions are mostly theoretical one. I will be discussing that in separate video. Thank you for watching.